Hey everyone, welcome to SF DroidCon and this talk on server-driven frameworks at Uber. I hope this talk helps all of you understand how we thought and designed server-driven frameworks at Uber. So before we jump into the topic, let me introduce myself. I am an Android engineer on the Rider Foundations team at Uber. And something that's interesting to understand is that this specific project is not restricted to Rider, but works across 3 different teams at Uber. And I have personally been working on this initiative for a bit over a year now. And when I first joined the team, I was in awe of the possibilities that can happen now with server-driven frameworks at Uber. And I hope to share that journey today with all of you. A lot of learnings here can help you evaluate other frameworks as well, even if you're not looking to build your own server-driven framework. The decisions that we made here can help you understand different frameworks or understand what's good for your project or your company in general. Let's look at the agenda briefly. We'll touch base on the significance and why should you even think about server-driven, followed by the goals that we had for our initiative specifically. We'll talk a bit about the solutions that complemented these goals, go deep dive into parts of the solution in detail. Then we'll cover a few challenges that we encountered on the way. We'll then cover what we invested in dev tools or testing frameworks in general and cover highlights at the end. We'll also leave some time for the questions if you guys have any. OK, now if you were paying attention to the very first slide, it said server-driven frameworks and not server-driven UI. So let's touch base on that a bit before we move on. Historically, server-driven UI has been about driving pieces of the layout from the backend. So to say how the button looks or feels and how the text on the button can change and things like that. Or at least we'll keep it that way for the purpose of this presentation. Now, server-driven frameworks are a larger abstraction beyond server-driven UI. They will let you control things like logic from the backend, updating data dynamically without re-rendering the whole UI, driving actions from the backend, observability, and many more things. We'll cover a bunch of these topics today. Before we move on to understanding what the server-driven frameworks at Uber is and what it does, let's first even talk about why should we even think about server-driven in the first place. What is not really working with the current method of mobile development? This slide specifically has a lot of details, but the highlight is that mobile deployment is particularly slow. And it takes almost 4 weeks to be able to land our changes onto the Play Store. And this is just about landing the changes. We then have to wait for users to actually update the app, which can take anywhere from 2 weeks to almost 6 weeks, 2 months to almost 6 months for 99% adoption. Now, we don't live in a perfect world. So we don't live in a perfect world. And what if you made a mistake and release your app? Now, most new features or bug fixes in general at Uber are guarded by feature flags. So you have the option to turn it off and reduce the impact that the user has to go through. But that also means that you have to make fixes again and go through the release cycle again, wait for a few more weeks before you can start getting insights and so on. The second topic that covers adding features to old versions is almost impossible with the current setup. What if you figured out a very simple fix that you can do, in case of Uber, maybe to just reduce cancellations, and you want to make sure that this change is shipped off to older versions as well? And some of you might ask, why do we even need that? Because you know that a lot of users are there on the older versions, and they have not really updated the app. With the current setup, it's almost impossible to send out updates to older versions. So now that we know about the problems and why were we thinking of server-driven frameworks specifically, we came up with a few goals that would help us drive this initiative forward. And these goals were a result of a bunch of surveys across teams, learning from our own past experiences of building these frameworks, and also understanding what sort of best practices we would like developers to incorporate going forward easily. So I'll be covering these topics very briefly, which were a result of our surveys. The first thing that we definitely wanted to cover was experimentation velocity. We wanted to make it very easy for feature teams to be able to have a good platform solution to experiment faster and get insights from their features. The second topic is around developer productivity. Uber had invested a lot into building its own mobile design platform solution, and we wanted to make sure that developers can leverage that and get things like accessibility, dark mode, and other best practices for free. And with the initiative of server-driven frameworks, we made sure that this was aligned. Historically, testing has been very hard in case of mobile specifically. So now that we are able to send down UI with data and logic in a single payload, it would make testing much easier inside sandbox environments. Let's understand how our solutions complemented these goals. So you see a bunch of text on the slide, but let's go over each of them very briefly. So at the bottom, we see Uber Design Library. This is the platform solution that we already had built for Android and iOS. We built server-driven layout using this design library now. And the server-driven layout basically is almost like, you can consider it almost like HTML, and lets you drive the entire layout from backend. Using the APIs from server-driven layout and callbacks from server-driven layout, we enabled you to write server-driven logic and server-driven actions also from backend. And using all of these frameworks, we built a very generic solution called server-driven features, which now lets you send a single payload with layout, logic, and actions, and we render the whole interactive UI for you. Now, one thing to notice and understand is that pieces of these frameworks are usable in isolation as well. So if your feature just needs UI updates and you don't need anything else, you can just go ahead and use server-driven layout. If your feature is not going to be changing UI over time and you only need to drive logic or actions from the backend, you can just use that part of the framework with native UIs. So it's all composable, and it's very easy to use with any of your UI paths. So before we move on, let's answer one burning question that you might have. Why did we not use any third-party solution? There are so many third-party solutions available outside. Why did we go ahead and build our own framework again to solve some of these problems? So the first one that's a highlight is UI-level control. Most companies of Uber scale would not want to give up control over UI and the debuggability that you get with native UIs. We already had a design platform that was available for us to use, so we were able to leverage that and have that UI-level control throughout our framework. The second piece that was extremely important for us was composability with native UIs. We wanted to make sure that we were able to leverage parts of the framework as we wanted with native UIs as well. And as we saw earlier, we could now leverage server-driven logic or server-driven actions specifically with native layouts as well. As a company, we also wanted to be sure of the number of tech stacks that we were using across mobile and backend engineers specifically. And this gave us a good way to leverage just two solutions that engineers would have to deal with on a daily basis. Now that we have a good idea of the goals that we came up with and a high-level idea of solutions, let's start deep diving into parts of the solutions. Let's start by talking about the UI and layout aspects of this framework first. Server-driven layout is really the first piece of server-driven frameworks, and it can be thought of as similar to HTML using Uber's design library. Now, what did we at Uber do to make this library a much better experience? So the first thing that's a highlight is definitely the backend DSL. And you can think of backend DSL as similar to Kotlin DSL, which lets you write type-safe builders. And this backend DSL in Golang now lets us write type-safe builders, type-safe payloads in Golang. And Golang is the language that we use primarily at Uber for backend development, hence the DSL is in Go. And as you can see here, the backend DSL makes it super easy to create the required payloads with the right properties instead of directly using models, which would have been very hard to read and understand and debug as well. With this layout library, we do have support for different types of layouts, like stack layouts, as you can see, which lets you position your child views either vertically or horizontally. And you can think of them as analogous to linear layouts, for example. This declarative UI approach worked really well for us over using a template-based approach. Moving on from the logic of UI, here is what else the library has to offer. This library now exposes APIs that we can use on mobile to update parts of the UI via observables of data. It also gives us callbacks from the server-driven UI for user interactions. So if you're tapping on a button or if you're tapping on an item in the list, it would give us callbacks with the identifiers for that button or identifiers for the list along with the position of the list tabbed item. Let's understand what this framework provides and what's next. So this entire framework on its on its own is very useful to start with for writing server-driven UIs. You can write the whole UI from backend, and you can write the whole UI from backend. But if you want to write any logic to update the data or state of the UI, you still have to rely on mobile build kits for that. If you want to write any actions corresponding to those button taps or list item taps, you again have to write logic on mobile for each of these. So with this framework and with the current problems, we came up with the next set of solutions, which is what we are going to talk about next. It is server-driven actions. Server-driven logic. So introducing server-driven logic. Let's first understand what logic even means and why are we not happy with it staying on the mobile side. Let's look at this example here. So we see two different versions of very simplified product selection screen, and I'm sure most of you would have seen this screen in some form. So the first screen that you see here does something simple. You tap on a product, and it says confirm UberX or confirm UberXL based on the product that you have selected. We wanted, first of all, to be able to drive this entire experience from the backend. Now, let's say you have this version in production, and you want to make some changes. Through research, you have found out that if you show specific text for, let's say, Uber Green, it drives better conversions. So we want to do that. So the second version shows exactly that. If you tap on Uber Green, for example, it say, yay, let's go green. So there's a different logic that kicks in based on the product that you are selecting. And we wanted to make sure that, first of all, the first version is completely driven from backend. And when we want to make updates and release version V2, that is also completely driven from backend. We didn't want mobile changes for this. So we'll talk about that example in a bit more detail again, but let's first understand in very simple steps on what server-driven logic is and how it helps reach that solution. In very simple terms, to understand what server-driven logic does, there's a payload that comes down from backend, which we resolve to an observable of primitives on the client side. And we finally hook up this observable of primitives into UI elements. So here you see a pretty simple example, which sends down a string logic from the backend. And in this case, the type is raw string. So on mobile, I know that whenever there's a raw string, all you have to do is take whatever is sent, push it into an observable, and then update the UI. So whenever this logic gets evaluated, the button will say hello world. Moving on, let's understand a more complicated version of the string logic, which we refer to as conditional string logic. And the name helps, I guess, but what it is doing here is based on a condition, picking a true logic or a false logic. So the condition here is a Boolean logic, and it can have any sort of comparisons, null checks, etc. But the thing to understand is that finally, it will emit an observable of Booleans. And mobile client will use this observable of Booleans to decide between a true logic or a false logic. And each of these true logic or false logic can, again, be very complicated string logic that will finally just evaluate to an observable of string. And this whole thing finally evaluates to an observable of string at the end. Let's understand this through a simple payload. So on the left side, you can see the payload, which just is a very simple check in this case. We kept it simple just to make sure that it's easier to understand. But the thing to notice is that it's, first of all, a condition type. And there's a true logic and a false logic, which is very simple string logic here. It's called foo and bar. And we have a Boolean condition that we are checking, which is, in this case, an integer comparison. Here we can check, where we can use any operator and check between two integers. That's exactly what is happening here. We check 1 against any other integer that you want to provide, and based on that, we either pick foo or bar based on whether it's true or false. So finally, in this case, if it resolves to true, it'll just emit foo or bar. Here is the mobile interface. This evaluator that you see here will have multiple evaluate methods, one for each of the primitive types. And based on what logic you're passing, if you're passing in a Boolean logic, it will evaluate to a Boolean. And if you're passing in a string logic, it will evaluate to a string, and so on. And we support 8 different types here. One thing to notice is the SLA config, and you can think of it more like a timeout configuration. So for whatever reason, if your Boolean logic is taking a really long time to evaluate, in SLA config, you can pass in a timeout, and second thing you can pass is a default payload. And this is really important because you don't want UIs to be blocked because some logic evaluation is taking a longer time. So you can provide defaults, and that way users don't have a bad experience. Now that we understand most parts of how server-driven logic would work, let's go back to the example and see what the backend code looks like. So the first step that we're doing here is simply just getting what the user has selected, which is in the vehicle title. And based on what the user has selected, we can now write a condition. And the second 2 sections are basically writing that condition. So the first condition that we check is if the user has selected Uber Green or UberX Share, in our case. And then we write a string logic based on that condition. So the last snippet that you see here is actually just writing that string logic. We know that it will finally evaluate to a string, and we do an if check that if it's green or share, then emit this particular string, otherwise just emit whatever the user had selected. And at the end, we are finally able to bind the string logic into the button title. And this is easily provided by the DSL. You can choose which property of the button you really want to update based on this string logic. And that's what happens here. So now that we have seen server-driven logic, what works now? Now you can send UI from backend and update it. And now you can also send pieces of logic from backend that will update the data or the state of UI. Here we saw data updates, but it can also be states like enabling the button, disabling the button, and things like that. There's one final missing piece that we'll cover now, which is driving actions also from the backend. Now we have made our UI interactive by moving pieces of the logic to backend. But there is still one piece missing. What happens when you actually tap on the confirm button? You want to open another screen via a deep link or have some other logic that you want to execute. That logic is still on mobile, and we want to move that also to backend. You might ask why. Probably because that's what we have been doing. But let's talk about some scenarios where this can escalate, and it makes sense to move this to backend as well. So today, let's say that tapping on that screen just opens a new screen via a deep link. And you want to change that deep link in the future to another URL. That's simple. You will say that, OK, I have a URL parameter in my backend, and I'll just change that. But let's try something else. Today, you are just launching a deep link, but tomorrow you want to chain 2 actions. You want to make sure that there is a certain piece of analytics firing, and then you are actually opening the screen. This should also be easily possible to do via backend instead of, again, making mobile changes. There can be other scenarios as well. Today, you are just firing a screen. Tomorrow, you want to do something really complicated. Tomorrow, you might want to make a network call, fetch some data, and use that data to show that screen. How would you do all of this without mobile build cuts? This is where Actions Framework comes in. And let's talk a bit about what the Actions Framework is, what all capabilities it has, and then see how we can leverage that to solve our problem. So talking about Actions Framework, you can think of them as broader functions that need to be executed on the mobile client side. And actions can be really generic, as we saw earlier, and we wanted to make sure that we are able to support that. So what did we do? We allowed backend now to send a stringified JSON in the action payload, and we now resolve them on the mobile side. And we also ensured that this action framework has capabilities like chaining multiple actions, so the capability for you to provide next actions and things like that. And again, as we talked about every other framework, this framework is completely composable with other parts of the framework, and it can be also used with native UI elements. One of the benefits that I want to highlight is the support for custom actions. A lot of feature teams will have very custom logic that they want to execute, like we cannot control how you want to make network calls or how do you want to use the response and things like that. So we wanted to make it very easy for you to support custom action elements at any point of time. And talking about the drawbacks, I think one thing that I want to call out is that adding new elements. So the library already supports a lot of generic action elements like opening screens via URLs, logging analytics, and things like that. But if you have specific requirements, it would still be on you and your team to actually just add a custom action element resolver so that it works on mobile. Let's start by understanding some of the components here of the actions framework. So here you see a backend. Here you see a model, which is used for opening a URL. And we said that we will be sending down stringified JSONs, which get parsed on the client side and have functions corresponding to them. So when we look at this payload here, and this is in Thrift, which is the ideal that we use, similar to Proto. And you can see here that we have annotations here, which we are using in Thrift. So the first annotation type is specifying that this is type action, which lets backend understand that this is one of the action models that it can use. And we'll see how we are using these Thrift annotations on mobile as well. And the second thing to notice is the version annotations for Android and iOS client. And this tells backend that this model is completely safe to be sent on mobile for this version onwards. To make sense of how these stringified JSON action elements are actually working, let's look at the mobile workflow. So on mobile, we ensure that we are creating resolvers for each of these action elements. And as we mentioned earlier, some of the generic ones are already created and added by the library. There is a registry here, as you can see on the client, or as you can see on the screen. And that registry maintains a map of key of action resolvers and the action element that it has to pick from. The mobile model gen, so when we talked about Thrift annotations, we also use that on the mobile model gen side. And mobile model gen actually ensures that these action elements are conforming to a specific interface. And that interface is then enforced on the registry by using generics. Let's see how this whole framework now evaluates on the mobile side. So mobile would receive the action payload and then call the library's evaluate method. The evaluate method now goes through the registry and checks for the matching action resolver. So in this case, if it's an open URL element, it'll pick the corresponding resolver to the open URL element and execute the function that's there in the resolve method. So in case of open URL, it's actually launching a screen by using the deep link URL. And actions do not return a value, as we saw for logic, but they can only just pass in success or fail. So looking at the previous example, let's understand how actions are being executed in backend now. So here is the DSL. And as you can see, there's a tap action that actually has the stringified JSON. And it actually in this case, it's pretty simple. It just has the URL that should be used on the mobile side. And when you see the button code at the end, we are now able to just add to whatever logic we had. So earlier, we had just added title that should be updated based on the logic. Now we are saying what should happen when you actually tap on this button. And when you tap on this button, this is the action that is being passed on to the mobile side. Mobile picks the correct resolver and executes that action. So now that we have these multiple frameworks that we had built, which is our driven layout, actions, logic, and all of these available, we tried to figure out a way to compile them together. So as a feature team, you should not need to deal with 3 different frameworks and call 3 different methods to make sure that everything works. So we wanted to ensure that we have a platform solution available for you to use if you would just wanted to use all parts of the framework. So let's see what were our challenges and learnings from coupling them together now. So when we built these decoupled pieces, they worked very well in isolation. when we started leveraging them, we found a lot of differences across Android and iOS. And these frameworks worked very well decoupled, but when we started bringing them together, there were a lot of issues that we started facing. And that's fundamentally because Android and iOS are not same. A lot of the callbacks are different. A lot of the data types are very different across Android and iOS. And since most of our logical code was depending on primitives, we had to ensure that we had the right adapters on either Android and iOS to convert them to the right types and send it back to us so that we could actually evaluate them. OS parity actually caused most of the issues here. Talking about state management. So when you looked at any of these features, we had to maintain a lot of state on our side to be able to get the state of the UI item that the user was tapping on and things like that, and also be able to write states. So when you tapped on an item, we were updating the state of the button. And all of that state management had to be maintained on the mobile side again. And this, again, caused some parity issues across Android and iOS. And the last thing is that anything that can be broken will be broken. And we saw that with a lot of feature teams in our case. If we left any piece of the framework open for users to use in ways that we did not intend, it was being misused. OK, let's talk a bit about dev tools and the testing frameworks that we invested in. So now that we had moved UI logic also to backend, we wanted to make sure that it was faster to develop and not slow developers down over time. So we invested in building a previewer app, which helped with faster compile times. You can just write the payload, spin up the previewer app. It already had an endpoint that was available for you to use, and you could easily see your changes through a local dev server as well. So quicker compile times, very rapid to iterate, and if someone had a bug in their feature, they could just upload it to a file on the previewer app, and it was very easy for you to see and test it out. This is an interesting one. So at Uber, we use Figma a lot as our design tool, and most of the designers there have access to building features using platform UI tools that we already have. Now in Figma, we built an integration to be able to use a screen and directly generate backend DSL code. So once you have the backend DSL code, it was very easy for you to iterate on them, add any other functionality, and spin it up and see it in the previewer app itself. Let's talk about testing a bit. So in general, all of our frameworks had very good unit testing, all the guardrails set up, and things like that. But we also went ahead and invested a lot in testing pipelines via CI integration. So the first thing to call out is snapshot testing that we did across Android and iOS. So whenever you wrote your payloads in GoDSL and landed the change, it would just make sure that it generates screenshots across Android and iOS, and you can see them in the diff itself and see if there are any major differences. The second thing that we are working on is cross-monorepo testing for logic as well. We already saw that we figured out a lot of logical differences across Android and iOS, and we wanted to make sure that it works the same for users across both platforms. So this is work in progress, but what we are doing is making sure that each of the logical pieces are same across Android and iOS. And the way that we think we'll do is have some sort of a log statement generated for Android and iOS, and then compare across them and make sure that it's all the same. OK, let's go over the highlights and what worked very well for us. So one of the highlights definitely is backend DSLs, which made it very easy to write type-safe payloads. Otherwise, it would have been pretty hard to write models by hand and be able to update and things like that. We also conducted extensive code labs and workshops to make sure that the framework had good adoption and people were able to understand. First of all, mobile engineers were able to understand how to write UIs in Go and things like that. And we talked about testing a bit, but we definitely made sure that snapshot testing was in place, and we are going to build logic testing also across monorepos. Composability was a big part of the framework, and this definitely helped because it made it much easier for feature teams to adopt parts of the framework and not having to understand the whole framework and build out the whole screen. Being opinionated was important, and this helped. In our case, for server-driven logic, we started with the fact that we are only going to support primitives, for example. And that helped because we were able to build a lot of guardrails around that. And we now have close to 20 plus features across Uber, and we have a few features that have been completely launched without any mobile changes at all. OK, thank you. This is all I had.